Okay, so this video is meant to capture the introduction for section 4.3, which is on synthetic division and finding the roots that way. So just as a precursor to synthetic division, this is going to be a shortcut to long division, which you guys did in elementary school with numbers. But synthetic division is basically long division with polynomials without all the visual clutter. So it's a lot faster and cleaner. To show you what I mean is, before you guys knew about fractions and decimals, you would solve problems like this. 13 divided by 3, for example, would equal 4 with a remainder of 1. So it goes in 4 times, but you have 1 left over. This was way before you knew how to do fractions or decimals. And you actually did this by long division. You would do 13 on the inside and put a 3 out here, see how many times it goes in, 4, multiply this, 12, subtract the difference, and your remainder was 1. And you guys had long, drawn-out long division problems. Well, we can do the same thing with polynomials. I won't go through the entire thing because we'll actually never do this, but you should understand where it comes from. If I wanted to do 3x cubed minus x squared plus 5x plus 7 divided by x minus 1. What I can do is I could set this up just like the long division. Put the 3x cubed minus x squared plus 5x plus 7 inside that little square root looking thing, and put the x minus 1 on the outside. Then you would see how many times does this go into 3x cubed. Well, just paying attention to the x, that goes in 3x squared times, and you would multiply and get 3x cubed minus 3x squared. Well, now you would take this and subtract, these cancel, minus x squared minus a negative 3x squared is a positive 2x squared. And carry this and see how many times this goes in. Well, that would be plus 2x, multiply, and then you get 7x here. Carry the 7 all the way down. And then you would see that this goes in plus 7. We have 7x minus 7. We end up getting 14. So the answer has a remainder of 14. Now, some of you are like, whoa, you just went through that really, really fast. Well, the reason why is because I just want you to have an understanding of, yes, this is long division. Yes, we can do it with polynomials. But no, you don't have to do that because there's a shortcut. So the polynomial, I'm going to use the same polynomial and now do synthetic division. But again, remember that the remainder is 14. So synthetic division is where we're going to take that same function, I'll just write it again, which was 3x cubed minus x squared plus 5x plus 7, and we wanted to divide by x minus 1. And the reason why we're doing this is because we're checking to see if 1 might be a root. We'll see more of that on Friday. And just for a reference, we're going to check to see that we get the same remainder. So now, if we're checking to see if 1 is a root, because remember it's always x minus root, we're going to put that little 1 in a little box. So it's not negative 1, we're putting 1 because it's x minus 1, x minus root. And so now I'm going to take all the coefficients. The coefficient of x cubed is 3, the coefficient of x squared is negative 1, coefficient of x is 5, coefficient of 7, well, that's just 7. And then we're going to set it up like this. Hopefully this looks familiar to you. You should have done this in Algebra 2, so this should be somewhat of a refresher. We're always going to carry this first number down, no matter what. And then we're going to multiply this number here by this number. Well, 1 times 3 is 3. Then we're going to add these two, and that adds to 2. Multiply, add. Multiply, add. And here's that 14. So this is a good reminder. I usually put a line here, or I box it off entirely, to show me that this is the remainder, and this is going to be my answer. If we start with x cubed, our answer is going to have a degree that is 1 less. So our answer would be 3x squared plus 2x plus 7. See how I got those numbers? And the remainder is 14. We'll talk about what the remainder means on Friday and what we'll do with that and why we're doing this. But right now, this is just how you do it. So to give you guys just another example, now let's do f of x equals 2x to the 4th minus 5x squared plus 1, and divide this by x plus 2. So in this situation, notice how this is no longer minus. So I'm going to set this up x minus root. This has to be x minus a negative 2. I'm going to put negative 2 in the box. Then I'm going to carry my coefficients, but notice how x cubed is missing? X is missing. We're going to put zeros for placeholders. So this is going to be 2, which goes with the x to the 4th. There is no x cubed. The x squared coefficient, there is no x, and then the 1. We have a higher power, so that's why we have more numbers here. Carry, multiply, add, multiply, add, multiply, add, multiply, and finally add. So that number is our remainder. Well, notice how many terms we have. And if we start with x to the 4th, our answer must start with x cubed. So the answer is 2x cubed minus 4x squared plus 3x minus 6 with a remainder of 13. So this is how you do synthetic division. But the next thing I want to tell you guys is that there's a shortcut if you only want the remainder, which sometimes is useful. Some of your homework problems only ask for the remainder. So there's this thing called the remainder theorem, which says, I'm going to abbreviate theorem. If we're doing a polynomial, f of x, divided by x minus r, where r is a potential root, then f of r equals the remainder. That's really important because all we're going to do is take this r value and plug it into x. So for the previous example, so I'm going to write this down for a second so I can copy it down on the next page. 2x to the 4th minus 5x squared plus 1 divided by x plus 2, and our remainder was 13. If we only wanted the remainder for that function, and I'll just make a note up here so we can compare that it was 13. We can just do f of, now again, x minus what number? So it has to be negative 2. We're going to plug in negative 2 here. We're going to get 2, negative 2 to the 4th, minus 5, negative 2 squared, plus 1. Don't forget that you need parentheses if you do this in your calculator. And this is going to be positive 32. This is going to be minus 20 plus 1. And that, in fact, is 13. So for some of your homework problems where it only asks the remainder, all you have to do is plug in the number there. So just another quick example. Find the remainder of f of x divided by x minus 1 if f of x equals 5x squared minus 2x plus 1. Well, now x minus root, the number we're plugging in is 1. So f of 1 is going to be 5 times 1 squared minus 2 times 1 plus 1. And this is 5 minus 2 is 3 plus 1. This is 4. And so the remainder is 4. Without having to do synthetic division at all. All right, good luck on your homework.